So on the first couple here, we have to solve them for y. We have to get them in y equals form so that we can read off the slope and y-intercept to graph them. So for the first one here, we have y has been multiplied by a negative 4, and the 2x has been added to it. So to solve it, we're going to subtract the 2x. So the 2x is gone on the left side. We still have the negative 4y. On the right side, we have 8 minus 2x. Well, 8 minus 2x is just that, 8 minus 2x. There's nothing we can do with that. Now, to get y by itself, I have to divide by negative 4. Remember, when we multiply or divide, we don't need the same name, so we can combine with every digit. We can multiply or divide every digit on both sides of the equation. So on the left side, we just have the one digit, the negative 4y. So we divide out the negative 4. We're left with y. On the right side, we have two pieces to divide. We have 8 divided by negative 4, which is just negative 2. We have negative 2x divided by negative 4. Well, negative divided by a negative is a positive. 2 divided by 4 is just going to be 2 over 4, which will reduce to a 1/2. And then we have the x. So when we go to graph that, we start out with the negative 2. That's the number that's been added or subtracted here. That means from the origin, we go down 2. That's our first point on our graph. Then the number multiplying x is the 1/2. So that means that from that point, we rise 1, run 2 to get to the second point. If those aren't far enough away, we can do it again. Rise 1, run 2. We get a third point if we need it. And our line goes through those 3 points. For number 2, same thing, we have to get y by itself. Here, y has been multiplied by 2, and then 3x has been added to it. So we're going to start by subtracting 3x. So the 3x is gone on the left side, leaving us with just 2y. On the right side, 4 minus 3x is just that, 4 minus 3x. Now we have to divide by the 2. Get y by itself. So the 2 divides out on the left side, leaving us with y equals. On the right side, 4 divided by 2 is a positive 2. Negative 3x divided by 2. Well, negative divided by positive is a negative. 3 divided by 2 is just going to be left as that, 3 over 2. And then the x goes on there. So when we graph this, we have the 2 as our starting point. That's what's been added or subtracted here. Tells us we start out at positive 2, so 2 above the origin is our first point. Then we have a slope here multiplying x of a negative 3/2. Remember, the negative always goes with the rise, which means from this first point we go down 3. Then we still run over to the left, or right, left to right 2. That gives us our second point. Our line goes through those 2 points. For number 3, if we only have one variable in the equation, to graph it, we need to solve for that variable. Here we have y minus 3 equals 1, so we're going to solve for y. We're just going to add 3 to both sides. Oops, I don't know where the 4 came from. We're going to add 3 to both sides. There we go. So that minus 3 is gone. We get y equals 1 plus 3 is 4. So y equals 4. We go 1, 2, 3, 4. It is a horizontal line at y equals 4. We go to positive 4 on the y-axis, and that's where that line goes through. Number 4, we have 2x equals negative 6. Our only variable here is x, so we're going to solve for x by dividing by 2, giving us x equals negative 3. So remember, when it's x equals, it is a vertical line, negative 3 on the x-axis, like that. Any questions on graphing any of those lines? Our next step was going the other direction. If I gave you the line on the graph, could we determine its equation? In most cases, that answer should be yes. Only two pieces of information we need for the equation. One is that y-intercept, which we abbreviated with a b. The other is the slope, which we abbreviated with the letter m. The equation will then take the form y equals mx plus b. Slope times x plus the y-intercept. So here in this line here, our y-intercept is right here. It's where it crosses that y-axis. That's it, plus 2. 2 units above the origin. So our y-intercept is just a positive 2, or just a 2. Slope usually takes a touch more work. We have to find 2 grid points, and in this case, we have those grid points where our line crosses the axes. The axes are on the wrong side here, so we got to draw in our rise and run when we're above the line. However, this rise will be the same as this distance here, which is 2 units. It is going up, so it's a positive 2. And our run will be the same as this distance here, which is 4 units. That's a run of 4. So we have a slope, rise of 2 over a run of 4. Both of those divide by 2 to give me a 1 over 2, or 1/2 slope. So that means my equation is y equals slope times x, so 1/2 times x, plus the y-intercept. The y-intercept's a positive 2, so plus 2. I'm going to have you try one in your notes, see if you remember how to do it. Give you a minute or so to find the equation of that line. So the y-intercept here is where it crosses the y-axis down here. That's at 1, 2, 3. So negative 3. 3 units below the origin. Our slope. Well, I have grid points here on the axes. That's my rise and my run. I rise 1, 2, 3. I run 1, 2, 3, 4, 5. So my slope is 3/5. That cannot be reduced. So my equation, y equals slope times x, so 3/5 times x, plus the y-intercept. Well, the y-intercept's -3. So I could do plus a -3 or simply -3. So y equals 3/5 x minus 3.
Sorry, can you scroll back up just for a second?
Sure.
Okay, thank you.
You bet. Now our slope isn't always that easy. It's not always going to go through grid points on the axis so that we can so conveniently count the rise and run like that. We might have points like this where we're given that this is the point 25 and this is the point 10, 9. Now remember, we could draw in the rise and run again, but the rise is simply the difference in the y coordinates. The y coordinates describe the rise. We go from 5 up to 9. So we said for our slope, the rise could be found as the difference in the y coordinates. We listed that as y2 minus y1. The run here comes from the x coordinates. We went from 2 to 10. So we said we could list that as x2 minus x1. So to actually put these in the formula, we have to label our points, point 1 and point 2. y2 is point 2, the y coordinates, so that'll be the 9, minus y1 is point 1, the y coordinates, so that'll be 5, over x2 is point 2, the x coordinate, which is the 10, minus x1 is point 1, the x coordinate, which is the 2. We subtract 9 minus 5 is 4. 10 minus 2 is 8. Both of those can be divided by 4. 4 and 8 can both be divided by 4 to give us a 1/2 slope. So we can take points off the graph, find their grid points or coordinates, and put them into that slope formula. Or just given the slope, we could just be given the points and not be given the graph. We might be just given the points, -3, 7, and 6, -5. If I want to find that slope, I label them points 1 and 2. I'm just going to use m for slope. Remember, it's y2 minus y1. Well, y2 is the -5, minus y1 is the 7, over x2 minus x1. Remember, x2 is the 6, minus x1 is -3. I'll put the -3 in parentheses so we see that it's minus a negative. -5 minus 7 is -12. -6 minus a -3 is a +9. Now, -12 and +9 can both divide by 3. -12 divided by 3 is a -4. 9 divided by 3 is 3. Now remember, we warned, we never turn a slope into a mixed number. It'll always stay as an improper fraction. However, we can move the negative out front to make that a -4/3 slope. Or we could leave it with the top if we wanted to. It really doesn't matter which. In your notes, a little review, find the slope of the line between, let's do -8, 1, and 4, 10. I'll give you a minute to find that slope, then we'll go over it. Let's take a look here. I call this point 1 and point 2. My slope, y2 is the 10 minus y1, which is the 1. x2 is 4 minus x1, which is negative 8. 10 minus 1 is 9. 4 minus a negative 8 is actually a positive 12. Both divide by 3. Give me a slope of 3/4. You also recall we were given, if I gave you that the slope equals 2/3 and the y-intercept was, oh, let's just do -3. If I asked you to write the equation, well, y equals slope 2/3 times x plus the y-intercept, so just -3. It's pretty simple. Generally, we're not given it quite that handily. We might be told we have a slope of a -1/4, and the line goes through the point 8,3. And I should specify here, we were told to find the slope intercept equation. That's the the form of the equation we've been working with so far all hour. So we know the equation starts out as y equals slope times x. So y equals -1/4 times x plus b, that y-intercept. Now, to find b, we know because the equation goes through this point that at some point on that line, x is going to equal 8 when y equals 3. So I can put 3 in for y and 8 in for x. And now the only variable left in that equation is b, my y-intercept. So we can solve that for b like we did last week. We start by combining what we can. -1/4 times 8 is -2. And then we add 2 to solve for b. We get 5 equals b. So that tells us the y-intercept equals 5. So now we know our true equation, y equals slope of -1/4 times x plus the y-intercept of 5. So there's our equation. In your notes, for a line that has a slope of 2/5 and goes to the point 5,3, find the slope-intercept equation. Okay, so y equals slope, so 2/5 times x plus b for our y-intercept. We put in the 0.53, so y is 3 when x is 5. We combine 2/5 times 5 is 2. And to solve for b, we subtract 2. We get 1 equals b. So our y-intercept equals 1. So the equation, y equals the slope of 2/5 times x plus the y-intercept of 1. We had mentioned that we could find the equation of a line given 2 points that it goes through. If it goes through 3, 1 and 9, 5, we could find the slope-intercept equation again. Our first step here is going to be to find the slope. We'll label them points 1 and point 2. Our slope, y2 is 5 minus y1 of 1. x2 of 9 minus x1 of 3. 5 minus 1 is 4. 9 minus 3 is 6. Both 4 and 6 divide by 2, giving us 2/3. So our equation, y equals slope times x, that'll be 2/3 times x plus b. Now we have 2 points to choose from. Does not matter. Remember, we saw on Friday or on Thursday, whichever one we picked is going to give us the same equation. So I'm going to use 3, 1. So I put in 1 for y, 2/3 times 3 for x. So I combine 2/3 times 3 is 2. To solve for b, I subtract 2, giving me that negative 1 equals b. So that's telling me that my y-intercept is negative 1. So that means my equation, y equals slope of 2/3 times x plus my y-intercept of negative 1, so minus 1. So there's my equation. Had I used the 9, 5, I would still get negative 1 as my y-intercept. In your notes, I would like you to do, find the slope-intercept equation for a line that goes through these 2 points. I'll give you a minute, then we'll go over it. Let's take a look. First step here is we have to find the slope. So I'll label my points 1 and 2. My slope will be y2, which is -1, minus y1, which is 5, over x2, which is 6, minus x1, which is -3. -1 minus 5 is a -6. 6 minus a -3 is the same as 6 plus a +3, which is 9. So that reduces to a -2/3. So I start out my equation, y equals slope times x, so y equals -2/3 x, plus my y-intercept, b. Now, it does not matter which point we use to try to find the y-intercept. I'm going to use, well, let's just use the 6, -1. So I put -1 in for y equals -2/3. For x, I put in 6. I combine what I can combine. -2/3 times 6 is -4. And then I solve for b by adding 4. -1 plus 4 is 3, so 3 equals b. Telling us our y-intercept is 3. And our equation, y equals the slope of -2/3 times x plus our y-intercept of +3. So there's our equation in slope-intercept form. So if I give you that a line has a slope of 3/4 and goes through a point 8,1, there is an alternative way of writing the equation for this. Rather than using that graphing form or that slope-intercept form, there is something called point-slope form of an equation. Point-slope form of an equation is y minus y1, that's our y-coordinate from the point, equals m, which is our slope, times x minus x1, which is the x-coordinate from our point. So that means we can just do y minus y1 is 1, so y minus 1 equals m is our slope, which is 3/4, times x minus the x-coordinate is 8. And there's our equation in point slope form. Now we have to be just a little bit careful here with negatives in our coordinates. Let's say I have a slope of 1/3 and it goes through the point negative 3/5. My equation, y minus y1 will be, well, y1 will be 5, that's the y-coordinate, equals my slope of 1/3 times x minus x1. Now, x1 is a negative 3. Minus a negative becomes plus a positive. So it'll look like that. Enough review. Wanted to go through all that because it's been a few days. And there is quiz 12-7 out there for you that is due at noon tomorrow. What is that, November 17th? So make sure you work on that quiz and get that done by noon tomorrow. For now, we're going to move on to a new topic. I'm going to have you graph two equations. Let's have you graph y equals 2x minus 3 and y equals 1/2 x. Oh, let's see here. Plus 3. So I'm going to have you graph those two equations quick. I'll give you about a minute, and then we're going to take a look at them and discuss what they mean. So for the first equation up here, I'm going to circle it in green. We start at negative 3. We have a slope of positive 2. Remember, I'll make that a 2/1, so it's a rise over a run, which means you go up 2 over 1. I'm going to do it again. up 2 over 1. Let's keep going. 1, 2 over 1. 1, 2 over 1. Only reason I'm doing that is I want to be very, very precise on where my points lie here. My second equation, I'll circle it in blue. That starts out at positive 3. That's my first point. From that point, I have a rise of 1, or a slope of 1/2. So I rise 1, run 2. I'll rise 1, run 2. Puts me right there. Now let's recall what these lines mean. This blue line here is the set of all solutions to this equation in blue. The green line here is the set of all solutions to that equation in green. In other words, I can pick any point on that line. Like this one right here is, what was it, 2, 1. If I put 2 and 1 in here for x and y, 1 would go in for y, 2 in for x, it makes that equation true. 4 minus 3 is 1. Any point on that green line, if I put it in, find its x and y coordinates and put it into that equation, it'll make that equation true. Any point on the blue line, if I put it into the second equation, it'll make that equation true. It is the set of all of the solutions to that equation. Well, today we want to talk about something called systems of equations. In a system of equations, we have 2 or more equations and we're looking for points that make all of them true at the same time. So this point here is on both lines. Remember we said each point on the blue line makes the blue equation true. Each point on the green line makes the green equation true. The point that makes them both true at the same time is where the lines cross. That is the solution to the system of equations. Now, because I drew this out so meticulously, I can see that that point is the point 4, 5. If I want to test that, I can come back to my original equations over here and test and see if that point makes each of them true. So for this one, 4, 5 is y5 when x is 4. 2 times 4 is 8, minus 3 is 5. So yes, it is true. I get 5 on both sides of that equation. For the second one, is it true? Is y5 when x is 4? Well, 1/2 times 4 is 2 plus 3. That is 5. I get 5 on both sides of the equation. So yes, that point makes both of them true. The solution to this system of equations is the point 4, 5. That's the one point that makes both equations true. Oh, let's see here. Let's try this one here. I'll give you a minute to graph both of those, see if you can come up with the point they cross. You got to be very careful. I should have warned you ahead of time. If you have grid paper that you can bring to class with you, now would be a great time to bring it in and use it. Makes these a lot easier to graph and find where they cross. Otherwise, you got to be very, very careful. But I'll give you a minute to try to graph those and see if you can find where they cross. So graph the top one in green again. We start out at 1, 2, 3, positive 3. Slope of a negative 2/3 means we go down 2 and we run 1, 2, 3. I'm going to do it again. We go down 2 and run 1, 2, 3. We get a point there. So our line goes through those points. Second one, I'm going to do in blue. We start at negative 3. From there, we go up 1 over 2. I'll do it again. Up 1 over 2. And one more time. Up 1 over 2. Notice I'm actually just continuing to do the slopes until I come up with points that hit the other line. And I find this coordinate here is 1, 2, 3, 4, 5, 6, negative 1. So that point, 6, negative 1, is a solution to that system of equations. Now, not all of our equations are going to be so nice and neat like that. We might have y equal, or y minus 2 equals 3/4 x minus 1. And 2y equals x plus 4. When I go to graph these, in fact, I'm going to move this one down a little bit to give me a little bit of room. Both of these have things that have to be adjusted. Y minus 2, we have to get y by itself, so I'm going to have to add 2 to both sides of the equation. Remember, when I add or subtract, I only have to do it to one digit, or one piece on each side of the equation. So for the y minus 2, the negative 2 goes away by adding 2. I get y equals, the 3/4 x isn't affected, negative 1 plus 2 is a positive 1. I may have screwed up my second equation here. Let me make an adjustment there so that that one works out a little better. Let's do that. So now to solve for the second one, before we graph it, we have to divide out the 2. Remember, when we divide, we got to divide every digit on each side. So on the left, the 2 divides out. We got y equals x divided by 2, well, we think of that as 1x divided by 2. And we just put the 1 over 2 times x. 12 divided by 2 is a positive 6. So we'll graph these. This first one here, we start at a positive 1. And we rise 1, 2, 3. And we run 1, 2, 3, 4. And I get a line that goes through those points. For the second one down here, I start at 6. And I screwed up again, but that's okay. I meant to have a negative x there, but that's okay. So we rise 1, we run 2. Rise 1, we run 2. And these points don't come together on our graph here. So here's one where we cannot solve it with graphing. Or we could, I suppose, if we had a really large graph. But these points just go off the scope of our graph. And this is an issue with graphing. There's two things that are issues with graphing. Problems with solving systems of equations by graphing. Problem 1 is large numbers. If we have really large numbers, we either need a really huge graph or the solutions are going to go off of the scope of our graph. The other is if we have solutions that are fractions or decimals. Trying to read fractions or decimals off of a graph is really almost impossible to do, especially when you're looking at two lines intersecting, trying to figure out what fraction or decimal they intersect at. Really rough to do. Okay, it's 2:20. It's time for our break. Let's go ahead and take 10 minutes. We'll come back in 10 and pick up from there.